frequency reuse. The reusing of the frequency which is there in the atmosphere or else which is allocated for our communication. When we try to make use of the same frequency again and again, we call it as concept of frequency reuse. So the concept of frequency reuse is utilized because we want better utilization of the frequency band which is allocated to us. So according to ITU, that is International Telecommunication Unit, the frequency band allocated for us is very less. It is from 9,900 megahertz up to 1,800 megahertz. For entire world, or the ITU now has allocated the 900 megahertz frequency to 1,800 megahertz frequency for radio communication signals to transmit in India. In between the range of 900 megahertz to 1,800 hertz, it is only 900 megahertz which we have, and there are millions and billions of subscribers who has a mobile phone. So all of us want to get connected. Unless until we make use of this frequencies which are available in spectrum, we cannot have the mobile communication take place. That's why the concept of frequency reuse is essential. And the frequency reuse can be obtained depending upon the distance maintained between one cell to the other cell. So what are the concepts that we need to keep in mind when the concept of frequency reuse is written is each cellular base station is allocated to the group of radio channels within the small geographic area called as a cell. That is, I told you about the cell. This this cell A, which is the base station that is allocated on campus, can work as one single cell. So, a cell is a small geographic area which consists of a group of radio channels in the small geographic region. And next, the neighboring cells are assigned different channel groups. Like how the SJBIT has other departments, that is around 6 departments. They are all called as neighboring departments. In the same way, there are neighboring cells which are assigned to different channel groups. And whenever there is a coverage area that is limited, we should have a boundary of the cell, and they may be reused to cover different cells. And the next one is by limiting the coverage area, the boundary of the cell has to be designed. And the next one is the interference levels has to be under tolerable limits. And the frequency reuse of the planning has to be done in accordance to the distance that would be calculated. So these are all how the cluster sizes and cell layout has to be designed. For example, here we have I is equal to 1 and j is equal to 1. And here we have I is equal to 2 and j is equal to 1, where this is one single cluster and this is two different clusters. Okay, so this is one cluster which has A, B, C, D, E, F, G, and these are the cells which is on the other side. Okay, and cell layout also it basically depends. See, you can understand the concept of frequency reuse in a better way here. This is which we have it as cell A, and if the frequency which is utilized by the cell A has to be reused, again the same frequency will be utilized only at this cell A, that is A1, A2, 3, 4, 5, 6 and 7. Okay, so whenever the same frequency has to be utilized, this much of minimum distance has to be maintained. This is what is important. And cell reuse example, that is, here there's a cluster which is formed of 19 cells. So to find the nearest co-channel neighbor of a particular cell, what we do is we move these cells in a chain of hexagon. These are all the hexagon shapes linked, which is highlighted as A. They worked as node, and they are turned 60 degrees in anti-clockwise, and the J cells are moved in the clockwise. Okay, so this is one of the method which is given in IEEE in one of the paper. So this is how the concept of frequency reuse will help us to have better utilization of the radio frequency which is available or which is allocated by ITU for the entire region. So what are the advantages of uh, frequency reuse, or as what are the advantages of cell sectoring? Other concepts are, it solves the problem of spectral congestion and user capacity. Means you can know, suppose if you go for a stadium to watch the cricket match, if around 40,000 or 10,000 customers are located in one single area, and if you try to make a outgoing call at the same time, you normally will not get connected. Means you can just take the example of sending a message or is a voice call on the day of New Year. Exactly at 12 a.m., though you try to send messages, it will be having a delay. And if you want to make a call, that is, suppose if I think most of you would have observed this, who has visited the New Year party in MG Road. Whenever you try to make a call to wish, exactly at that time, your calls will not get connected. The main reason here is congestion, spectral congestion. Okay, and the user capacity. More number of subscribers cannot utilize the cell at the same point of time, because the congestion of the cell spectrum will take place. So this concept of frequency reuse will solve one of the problem of spectral congestion. So that because the same frequency is utilized only after maintaining some distance. I gave the example. If this cell is making a utilization of the frequency 905 megahertz, then once again the cell A2 will make use of the same frequency after coverage or area of particular distance. That is one thing. And second advantages of cellular concept is it offers high capacity in a limited spectrum without major technological changes. Means whichever the tower you take, we have the same tower, we have almost the same number of antennas, everything. So it offers high capacity with limited spectrum without major technological changes. Means we mount the same towers at the same height, we mount the same antennas, we have the same receivers, same transceivers. We are not making any change, whichever the tower we implement. The next advantage is reuse of the radio channel in different cells is one of the major advantage. Like you know about recycle, reuse and reconfigure. Here also same. And it also enables a fixed number of channels to serve an arbitrarily large number of users by using the channel throughout the coverage region. These are the advantages of cellular concept. And there are techniques called as cell capacity expansion techniques in cellular systems. So what are the three techniques? One is cell splitting, that is instead of accommodating 100 subscribers per cell, if this cell A can accommodate 100 subscribers, then how do we try to accommodate few more subscribers? Means instead of 100, if I am able to accommodate 150 subscribers, how do I make it? This is achieved by the technique called as cell splitting, cell sectoring, or as it can also be achieved by coverage zone approaches. But Most widely, we make use of the cell splitting or cell sectoring techniques to expand the cellular system. Means we try to accommodate more number of subscribers in a cell. So what is cell splitting? A cell splitting is one of the methods used for expanding the capacity of a cellular system, which is done by splitting one mega cell into a micro cell. So this is a mega cell. So this is the mega cell. This hexagon cell is the mega cell, and this mega cell will be once again framed into a micro cell. This is a macro cell or a mega cell, and this macro cell is divided into a micro cell. So this cell is A and this cell is A1. So what we'll do is this cell A will provide the will facilitate 100 subscribers, and this cell A1 will accommodate 50 or another 25 subscribers. So totally now we can run this service for 150 subscribers or 125 subscribers. But a designer, a cellular system designer has to think about it, where suppose if the radius of this cell is around 50 kilometer, then the total radius of the microcell should be 1/4 of it. Means it should be 12.5 centimeters or else 12.5 kilometers. So this is how the cell splitting method is approached. A cell splitting method is one of the method which helps to expand the capacity of a cell, where a macro cell is divided into a micro cell, where the size of the micro cell is 1/4 of the macro cell. And if the name of the macro cell is A, the name of the microcell would be A1. So like this, in a cluster, whenever we have a cluster of 7, if I divide this entire cluster into microcell like this, B1, C1, A1, like this, then instead of 7 cells, now I have 14 cells, which is multiplied by 2. And in before, the 7 cells were able to facilitate 700 subscribers. Now the same 7 cells can facilitate additional 350 subscribers. So now it has increased from 700 to 1050. So this is the advantage, and we can understand how the method of cell splitting will try to enhance the utilization of the spectrum. Okay, like how whenever there's a room in the house, if you want your friends want to just come for combined study in your to your residence itself, just you try to accommodate 2 to 3 more friends in your room. Instead of you staying alone in your room, you try to accommodate 4 more of them in one single platform. Okay, so this is how the cell splitting, where the cell is divided into macro cell is divided into micro cell. Subscribers can be utilized. Who is that muting me? And again in your class, the you people are muting your friends. Please stop all those behaviors in the class. So this is about cell splitting. Next, cell sectoring. So this is cell splitting, where cell splitting increases the capacity of the cellular system since it increases the number of times the channels are reused. And in cell splitting, the new cells, which are the smaller radians than the original cells, are called as microcells. And the cell splitting increases the capacity due to additional number of channels per use area. Cell splitting is the process of subdividing a congested cell into smaller cells with its own base, corresponding reduction in the antenna and power transmissions. So this is cell splitting, what I explained you. It is microcell. This is the cluster which has 21 cells, and now this is subdivided into microcell. So this is a macrocell and this is a microcell. Okay, so this is what we call it as cell splitting. So interference is reduced when we go for the cell splitting. So here you can see splitting cells in each cell. That is, this is one cell and this cell is split into 3 more. Okay, 3, 4, 5, 6. This is only for illustration. In the exam, you don't have this diagram to be drawn. It's only for your understanding. And next comes the second one, that is cell sectoring. I just want to finish this topic in today's class. So please bear me with for next 5 more minutes. Okay. And here the next 2 hours is FON, which will be going for 2 hours. I'll just inform Uma ma'am to start the class with slight delay. Okay. Let me first complete with this sectoring so that the entire topic is over. What is sectoring? A sectoring is a technique where the area of the cell is not reduced. We are not touching anything with the area, but we try to add few hardware devices to frame into sectors. Means whatever the cells that we have, they are framed into sectors. Okay, suppose for example, in your class there is a strength of 75 students, and if I want to make you people work with a project, I cannot give a single project for all the 75 students. But instead what I do is, I will divide the entire class into a group which has each student, where each group has 5 number of students, and so I'll form around 11 groups. Okay, so there will be 11 groups in your class, which is of each of 5 students. Okay, so like that, here we have the sectoring. A sectoring is a method where we are replacing the single omnidirectional antenna by several directional antennas. So the main disadvantage in sectoring is we are making the hardware components more. We are enhancing, or else we are duplicating the number of antennas which is used. That's the problem in sectoring. And only advantage of sectoring is the corner channel interference can be kept stagnant. Means it cannot be changed. It remains the same. That is the only advantage of sectoring, cell sectoring. But whenever we want to go enhance the cell capacity expansion techniques by sectoring, the sectoring is done by replacing the single omnidirectional antennas by several directional antennas. You can see here, this is tower. This is figure A and figure B, where the sectors has been formed, and here you can see the diagram. You can see on this. So this is the antenna which is mounted on the tower. This is the antennas, vertical antennas, or the folded dipole antennas, which people have studied in the previous semester. So this comes under sector 2 and this comes under sector 1. Okay, so on the tower these three antennas are formed as sector 1 antennas, and these three antennas come under sector 2. So the coverage area is totally increased. But one disadvantage is more number of antennas are utilized. So this is the disadvantage of sectoring. And this are all what we call as antennas. Multiple antennas are used where the radiation is taking place in one particular direction. So these two topics are not important for your things to be understood. So this is all about cell sectoring. Cell splitting, cell sectoring. A cell sectoring is a method where the single omnidirectional antennas are replaced by several directional antennas. And depending upon that, the cluster is formed into sectors where the subdivision of the cells will take place. Okay, so this is a cluster which has about 1, 2, 3, which has about 84 cells which is connected. So they are formed into sectors, sector 1, sector 2, sector 3. And each sector will have a separate directional antenna, not a omnidirectional antenna. So the major drawback when we go for cell sectoring is the hardware components used in the system implementation is increased. It's very large. So the implementation cost goes high when we go for cell sectoring. So that's why the best method which we try to utilize is cell splitting rather than cell sectoring. Okay.